Hi. I'm Bruce Eckel. I'll be your session chair for the next 3 sessions. They wanted me to make an announcement about there's a 10-minute break between sessions, so you don't need to rush out before the session's done to try and get to the next place. It's not clear on the, what, you're shaking your head? Okay. Anyway, let's get started. Our first speaker is Noah Swartz.
Hi everyone, welcome. I'm Noah Swartz, and I'm here to talk to you about encrypting the web. So in this talk, I'm going to talk a little bit about Let's Encrypt, the project, and then I'm going to talk about Certbot, which is a client for Let's Encrypt, and I'm going to be mostly talking about packaging it and distributing it. But first, let's talk about Let's Encrypt and what it is. So Let's Encrypt is a free automated certificate authority, and it's run for the public benefit, so it's a nonprofit. And it's a service provided by the nonprofit ISRG, the Internet Security Research Group. They give people certificates in order to enable HTTPS on their websites for free in the most user-friendly way that they can, which they believe is to automate this process. If you're unfamiliar with certificate authorities, those are the things that allow websites to be HTTPS. So when you're browsing the web and you see one of those green lock icons, it might be from one of these certificates that Let's Encrypt has issued. Let's Encrypt has been going on for a long time. The first commit to our code to get it working was all the way back in 2012. And we started issuing certificates at the end of 2015. So this isn't just something that happened overnight. It's been a long process. And so it wasn't until the end of last year that we were trusted in browsers as a root CA. But that entire time, the client that I work on, Sirpato, has been in progress, and just earlier this month, we released 0.14.0, which is our 14th major revision, and we're going to keep releasing approximately monthly for the foreseeable future. So to explain some of these terms, Let's Encrypt is the certificate authority, which is the authority that verifies that a domain is the domain that it says it is and issues it the certificate. Certbot is the project that I work on, which is the client for Let's Encrypt. It's what your web server uses to talk to the certificate authority to prove ownership. And I work at the Electronic Frontier Foundation. And Certbot is an EFF project. And initially, Let's Encrypt was also an EFF project, and we co-founded it along with Mozilla and the University of Michigan, along with a bunch of sponsors. So Akamai and Cisco were there from the beginning, but now there are a whole bunch of people who are donating to keep Let's Encrypt alive and to help the internet be secure. And because we're able to keep Let's Encrypt going, we can rely on the certificates that it issues to as like a sort of a public resource to keep the web secure. And so if you work at a large company, you too might consider becoming a sponsor of Let's Encrypt and keeping it alive. So why would you want something like this? Like, why do we need HTTPS certificates? Well, first off, having secure websites, having HTTPS on your website will protect your users from government surveillance, from projects like XKeyscore. It will also protect them from ad injection from captive portals or malicious ISPs. So this is a picture of a captive portal that might be sold to like an airport that would inject ads into unencrypted websites. It's hilariously named Revenue Extraction Gateway. And the reason why we want the certificate authority to be free and to be automatic is because previously these certificates cost a lot of money. So a lot of people who ran small websites that weren't businesses themselves didn't want to get these certificates because they didn't want to spend the money to buy them. And additionally, it's automated, so inexperienced sysadmins, people who don't want to know all the intricacies of their web server, could still get certificates. So there's a hilarious video that was filmed for DEF CON, the DEF CON presentation announcing Let's Encrypt 2 years ago, where my coworker comes into my office before I was working on Certbot, asks me to try to get a certificate from one of these free CAs, and I spend 4 hours not able to get a certificate. Now you can get one in about 20 seconds. And additionally, when a big security issue happens and everyone needs to get new certificates for their websites, like something like Heartbleed, you can just script that. Everyone can get them instantly. They don't have to go back and remember all the things that they did a year ago to get one of these certificates. It's stored on their computer in a configuration file. So how successful has it been? Well, as of earlier this month, we've issued around 40 million certificates. And that makes us, by kind of a wide margin, the largest certificate authority on the internet. Yay. Because a lot of the websites that we issue certificates for are these smaller websites that are personally run, we're not necessarily responsible for a lot of the traffic on the internet being encrypted, but we are responsible for just a sheer number of websites being encrypted. And by various accounts, Certbot is responsible for somewhere between half and 3/4 of all of those issuances. So that means a lot of certificates are coming from Certbot, which means that it's running a lot on a lot of computers. To give you a sense of how many computers those are, this is the graph of OSs that we support and how much they're used. And so you can see, like, there are some well-known operating systems up in that top quarter, Ubuntu, Debian, CentOS, but that long tail is super, super long, and we have to support all these OSs. So that's not even a complete list. That's one of 3 pages of lists of operating systems that we run on. And you can imagine trying to get a program to work on all of these OSs is kind of a pain in the ass. Additionally, we wanted to make it automated for people, so we support automatic configuration with Apache and Nginx, and the reason why we did that is because together they serve about 2/3 of all websites on the internet, with Apache serving still almost half of the sites on the internet. So we felt that if we can make it automatically configure those web servers, then that would help a lot of people who aren't as knowledgeable about web server configuration be able to get an encrypted site. And one of the ways that we do this is we provide a website at certbot.eff.org. You can select your system and your web server from a drop-down list, and we'll give you detailed instructions on how to install Certbot and how to then configure your web server. And you'll notice that even there, we still have to provide like a lot of hand-tailored instructions. Certbot's written entirely in Python. Why did we pick Python? Well, because Python's great. I don't have to convince all of you. But it's easy to use. A lot of people know how to read and write it. And for this application, it doesn't matter that Python's not the fastest language in the world. You're running a renewal probably once every 3 months in most cases. And it doesn't really matter if it takes 7 seconds instead of 5 seconds to do that. You're still not going to have a problem getting that certificate. And we really wanted it to be automated because we really want people to be able to sort of set it and forget it. Do a configuration once and then always have an up-to-date certificate on their web server. And for all those people who had never gotten certificates before or couldn't, we wanted it to work for those people. So what Certbot is doing is sort of doing a challenge response protocol with the Let's Encrypt Certificate Authority just to prove that you own the website you want a certificate for. And then, as I said, it installs that certificate if you're using Apache or Nginx. And a number of people have written third-party plugins for other sort of server architectures, but Apache and Nginx are the ones that we maintain, which means that we have to have libraries that do that configuration. So how do we get Certbot to all the people in the world? It sounds great, but people need to install it. Well, it's just Python code. Yeah, it's just Python code. They can just, it's just on GitHub. It's an open source project. They can just download the code and run it, right? I mean, it's just a Python program. Well, almost, except that we have a lot of Python dependencies because we have to do all of these fancy things to get people's certificates. So if someone downloaded our code from GitHub, they would have to install all of these libraries on all of the right versions to be able to run that code. Well, you might think, that's not such a big deal. We have pip. It's a package manager. It will figure this out for you. You write a big, detailed requires.txt. It'll download all these dependencies for people, and then they're fine. Almost, except that because of some of the things that we're doing, those Python libraries on this list rely on operating system level dependencies. So for a number of these to build, they have to have the right versions of these dependencies to be able to work. And so if the user doesn't have these operating system level dependencies, then they can't build those Python libraries, and then they can't use Certbot. So we came up with a solution for this. It's called Certbot Auto. It's a bash script which does all those steps, and it's bundled all into one script. When we came up with it, yes, we could have tried to package it for various operating systems, but we just didn't feel like we could maintain that. So we thought that this would be a good stand-in. We'll write a script. It'll try to download all those operating system dependencies. Then it will build you a virtual environment, download all those Python libraries, and then try to build and run Certbot with the commands that you specify. And this works pretty well. It's definitely helped us a lot. It's gotten Sirpato installed on many of those operating systems that I mentioned, but it's not perfect. So it's kind of hacky. You have to do all of this special case if-else for all of these different operating systems to try to get a working version of all of these dependencies, all of proper things. So here, you can't really read it, but it's just like, try this, try this, try this. And at the end, it errors out and says, like, sorry, we tried everything, but like, we still can't get these operating system dependencies for you. So it's kind of hacky. And understandably, people are kind of scared about running a script that installs things on their computer, because you don't know what kind of scary hacker wrote that code. And I mean, I wouldn't want Certbot to destroy my website, so I think people are reasonably afraid. But we spent a lot of time trying to make sure that we verify all of the things that we're installing. So not only do we verify the hash of that Certbot auto script, but we also verify the hashes of all of those Python libraries. For a long time, this wasn't something that pip could do. It was, one of our contributors, Eric Rose, made this package called peep, which does hash checking for Python libraries. So thank you, Eric, for making that. Now it's bundled into pip, and so all of you can get that same benefit of being able to check the hashes of the Python library dependencies. But even though that's now in pip, we still have to support a lot of legacy systems. So we can't guarantee that everyone who is installing Certbot has a version of pip that supports this hash checking. So Eric came in and saved the day again, and he made this project called pipstrap, which will make sure that the user gets to a version of pip that then supports hash checking to then get all of the verified libraries. On top of that, these, yeah, so dependency hell. These Python libraries depend on system libraries, which depend on system libraries, which then maybe are out of date. And so there's a lot of Python libraries, as I mentioned, that really rely on these OS level dependencies, and many of them really need to be the exact proper versions, otherwise they won't build. And if either of those versions shifts, the whole thing breaks, and then Certbot stops working. And so we have to do a lot of tricky, fussy things to make sure that we have the right Python library version for the right OS level dependency. And it can be kind of hell. So you would think that those Python libraries could just ship a compiled version. Unfortunately, it doesn't work for everyone. So in this situation with Python cryptography, they can't just ship a built wheel of that Python package because they can't always guarantee that they'll find the right API bindings for that C code OS package. And even when you get that to work, you've compiled it and it works. If that OS package changes and it changes its API, it breaks everything for you. And it turns out that that API changes pretty frequently, so that breakage happens a lot. In addition, pip itself is not perfect. So pip, you'll see this bug from this issue from 2013, which complains that pip doesn't do dependency resolution, and it is still open. Pip still does not do perfect dependency resolution. And then Eric has this comment from a different bug where you can have a lot of different things that specify the versions of your packages, and if they're read into pip in the wrong order, other packages that you rely on can overwrite your requirements. So you'll remember back up in that slide where I list all the Python libraries, we've specified the version number for all of those. But some of those will then specify some of those packages as dependencies, and if they specify a different version number, pip will just forget about our requirement, and then Certbot won't work. So Certbot Auto has some problems. It works pretty well, but it's not perfect. For one thing, it relies on pip. And as I just said, pip doesn't have dependency resolution. And all of these different things can overwrite your dependency resolution. Additionally, using pip to get all these libraries and building them on people's systems requires that they build it on their systems, which takes a lot of time and a lot of memory. So people on small computers aren't able to do that necessarily. So people running Raspberry Pis or very small like virtual machines like DigitalOcean droplets don't have enough memory to build these dependencies and can't use Certbot Auto. It's hard to ship system-specific solutions for people. So if you want to do something that's not a system package and not a Python library, you don't have a good way to put that onto their computer. So for example, we wanted to ship specific config files for this thing that reads Apache configuration files. And we don't have like a good way to do that except to like write it into this script and then like hack it onto their system in the right place and like hope that we figured out the right place on their system. Whereas if someone like packaged it, they could build that into the system. And because you're updating this script, so Sirpato Auto updates when it runs. It checks pip for the newest version of itself and updates itself. We're really inspired by projects like Chrome or Firefox that seem to magically know when they have a new version that you need to make. But because we're doing that outside of a package manager, you don't have a good way to update that program without running it. And so people who have scripted it and where it's running in the background, they don't get that prompt to install new OS dependencies. So it's very hard for us to change what it's doing once it starts running because people aren't getting prompted to update it out of bandwidth running it. And additionally, yeah, it needs to update itself. So we need to like move it around so it doesn't overwrite the script while it's running, which isn't so bad, but is kind of like an annoying hack. But as I just mentioned, we could package it. So our problems, our real pain points in this last slide are that we need to build all these things on people's systems. We have to make guesses about what works on their system. And everyone has a different system, and it's confusing. Well, luckily, all of these OSs that people run on have different package managers and maintainers who know a lot about those systems. So why don't we ask them to package this thing for us rather than relying on pip and this homebrewed script. And that works pretty well. So people who are very knowledgeable about these OSs get to fix all those problems for us. Those Python dependencies are built not on the people's systems, so we don't have to worry about their memory. We have real dependency resolution. It's great. And these maintainers can make those system-specific changes. So they can put these extra config files elsewhere on the system because package managers have a way to do that. And we don't have to necessarily rebuild every time we run or check to see if there's a new version because the package manager is going to tell us if there are updates. Additionally, we don't have to like mess around with this virtual environment because we'll have packaged libraries for that system. And we're not worried about, we'll know the version of these Python libraries or OS libraries on their system. We don't have to like hide it away in a virtual environment. And we don't have to make that horrible Certbot auto if-else because we're building it specifically for every system. But it's not perfect. Even this has problems. So because the distribution method is out of our hands, we can't guarantee that people have the most up-to-date version of Certbot. With Certbot Auto, we just push it to pip. All of the Certbot Auto things check to see if there's a new version in pip. But package maintainers are now in charge of distributing this package. If they're busy or if their system has a reason that they don't want to include new packages, they could have a much older version of Certbot than the one that's in pip. Additionally, maintainers can make system-specific changes. And because they're not Certbot developers, sometimes they can do things that end up breaking what Certbot does. So we had an example where we have, so Certbot will offer to renew your certificates. If you call renew, it will remember the configuration that you ran Certbot with initially. Different people have different ways of scheduling renewal on their computers. And we had one of our maintainers change the renewal thing to something that made sense on their system. Unfortunately, when they did that, they did it in such a way that it wouldn't respect the existing renewal configuration files. And in fact, if it ran, it would overwrite those existing renewal configuration files, and all of the renewals would fail for everyone who had anything set. They didn't do this maliciously. They just didn't know about Certbot in the same way we did, and we didn't have this thing very well documented, so they didn't know about these intricacies. So it's great. Maintainers are really helpful and really useful, but they're not Certbot developers, so they can still cause problems for you. And those OS packages can still move out from under you. They get updated separately from Certbot, and if you don't push an updated Certbot release, you can still get a different version of an OS package. Yeah, and we're still not at 1.0, as you noticed. We're on 0.14.0. So we're still making changes. So people who have long-term stable releases don't necessarily want to package us or don't want to have to deal with updates to our script. And we might be frustrated that we want to give people new features, but their operating system is unwilling to package it for them. So that's the problem with making your own script or relying on package managers. If you're like us and you've chosen to do both, you have a whole new class of problems, which is now you have multiple distribution methods for this package, which means that you can't necessarily make guarantees about what version someone has on their OS, nor can you make guarantees about which direction they're going in versioning. So let's take Ubuntu for an example. For a long time, Certbot wasn't packaged in Ubuntu. So we told people to use Certbot Auto to get Certbot. Then, Certbot was packaged in Ubuntu. And that worked a lot better for people. So we started suggesting that people get the packaged version. But if you switched from Certbot Auto, you would move back in time to an older version of Certbot to the one that was packaged. And additionally, now we have someone who maintains a separate PPA that's downstream from the Debian PPA. So now, on any version of Ubuntu, you have 3 options which will all give you different versions of Certbot. Which means that if we ever want to change any of our configuration files or any of the information we store, we have to think long and hard about if this will break things for people who are on older versions of Certbot or move to older versions of Certbot, which makes it hard for us to make changes. So what will we do in the future? Well, it seems like our problem with packaging it natively, it works very well, but we can't make super great guarantees about all of the OS dependencies that we have, or all of the things that we've built. So we might move to something like PyInstaller, which will build the package and then distribute it, or do something like what Chrome does and distribute built.debs or .rpms that include all of our dependencies. And then we don't even have to worry about how packages are moving around in the system. We've found a stable version, and we've sort of stitched everything together, and it just works until we push a new stable version. So what would help, so those are all of our problems. What would help us in the future? Well, if these Python packages that rely heavily on OS packages could find a way where they won't break those API bindings, that would help us a lot for something like Certbot Auto. Either they could vendorize it, they could ship an included binary, they could try to find those API endpoints dynamically when it's built, or it's not ridiculous to think that you might want cryptography code in the Python standard library. If it was built directly into Python, we wouldn't have to rely on any of these things. It'd be great if pip had dependency resolution. That would be nice. Or if we could find a way to make that make more sense for us and not have to sort of, code all the edge cases. But it's not all necessarily Python's problem. It's not ridiculous to think that Certbot could just be written into one of these web servers. If Certbot was just a core functionality of Apache or Nginx, we wouldn't have to do anything. Everyone with Apache and Nginx would just have it already by default. And if we had more package maintainers to help us figure out all of these OS-specific problems, that would be really helpful. I mean, we are already getting tons of help, and we're very appreciative, but we're a small group, and they're already volunteers. So the more hands make lighter work. So what have we learned? There should be some takeaways for this. If you're making a project that you're going to try to distribute in this way that a user runs, you should think long and hard about what Python libraries you want to rely on. Just because it works on your system doesn't mean it's going to work on everyone's system. They're going to have different dependencies and different package managers that get them different versions of those things. And you don't want to run into the problem which we had, where all of your OS dependencies are breaking all of your built Python libraries. Distributing Python is hard. Pip isn't a package manager like something that's built into an OS, and you can't rely on it as such. Additionally, you might just want to use one distribution method so you can make guarantees about what versions people have of your package. And so something we did early on in Sirpato Auto is we didn't prompt the user before we installed OS dependencies. We just installed them on their system. Do not do this. That is horrible. People, understandably, got very mad at us because it broke their web servers. So if you're going to be installing things that corrupt or change a user's OS, you should be very responsible when you do that and ask for permission. You should sort of prioritize stability. You want your project to work and be in a state that works consistently for people. which is maybe saying package it as one of those .debs, or like get to a stable release so it can be bundled into stable operating systems. The other lesson is the maintainer community is really great. They've been super helpful throughout this whole thing. So big thanks to a lot of the people who have really helped with this. Eric Rose, who I mentioned a ton of times in this talk, has been invaluable. Brad Warren, who's my coworker at EFF, helped me prepare for this talk. But also we have a bunch of contributors for a bunch of those dependencies who will do bug fixes for us when things break. So thank you to all of them, and thank you to all of our package maintainers. There's a long list. They're all wonderful. And thank you to all of you for coming to this talk. And if you think this is a cool project, you can contribute to it. So we have a GitHub repository. All of EFF's code projects are freely licensed. You can contribute to them. I'm going to be sticking around for sprints. You can help with Certbot. And even occasionally, EFF is hiring. You can come be my coworker. So if there's any time, I'm happy to take some questions.
We have like 3 minutes for questions. If you would
3 minutes for questions.
If you would come to the microphones here, because this is being recorded and we want the...
Hi. So I work for Continuum, so full disclosure there. I was just wondering if you considered Conda for your packaging and if that ever came up in your discussions. Conda, the package manager?
No.
Oh, OK. So that's
but let's talk later.
Great.
Maybe you found the answer to all of our problems.
Hi, I was just wondering why so many dependencies. I mean, I've seen dependencies on IPython and IPDB, and I just don't understand why you need so many dependencies and such as these ones in Let's Encrypt.
It's a good question. We have a lot of dependencies. A lot of those are necessary for some of the core functionality of Sirpot. Some of those are necessary for some of our tests. So you might have seen some things that work with our test infrastructure. But a lot of, we specify a lot of dependencies in there to get around sub-dependencies of those libraries. So some of those might not be direct dependencies to us, but we just want to verify, like make sure that we have the right version of it. And so they might be dependencies of those other packages.
OK, thank you.
I'm not sure if you're aware of the distutils SIG special interest group mailing list, but there's actually somebody who's working with the Google Summer of Code to work on a dependency resolver for pip. So
that's great.
Just
what great news. OK, I'll look that up.
I was wondering if you'd considered also distributing a like a containerized version so that someone could just have a completely separate container from all of their existing packages on an OS instance.
Yeah. Well, one of the things that we really want to do is to make this work for people who are like inexperienced inexperienced system maintainers. And once you get into a container, especially with something like this that needs to talk to the outside internet to do that handshake with the Let's Encrypt CA, you have to do a lot of fussy things to port forward those containers. And I think the overhead of getting someone who barely knows how to configure their Apache setup to use Docker and then do this challenge response is too much. We work pretty well on most operating systems now that it's less of a priority to have something entirely foolproof that makes more of the burden on the user to install it.
Thank you.
Mm-hmm.
All right, thanks, Noah.
Cool. Thanks, everyone.